Hello grade 10, this is Miss Hughes and this is a podcast about surds. Now you did a lot of surds in grade 9 and we also have covered it a few times this year, so I don't want to make this podcast unnecessarily long. If you want to work through the questions yourself and then just check the answers, that is fine. I'm just going to show the workings but not go through in detail. Okay, so it's really helpful to have the square numbers at the tip of your fingers, so make sure you've memorized those. When we simplify a surd, we try to make the number inside the surd as small as possible, and we do that by looking for multiples of square numbers. So 99 is a multiple of 9, 32 is a multiple of 16. 32 is also a multiple of 4, but we always try to find the biggest square number. Little hint, always put the square number first. It'll make things simpler in the long run. So I've rewritten root 99 as root of 9 times 11. Now I'm allowed to split that product. That is root AB equals root A, root B. So I can split that product into root 9, root 11, and I know that root 9 is actually 3. So that gives me 3 root 11. Same here, root 16 is 4, gives me 4 root 2. Nothing new. Okay. Here we've got 5 root 2 plus 2 root 2. If at times you get a little bit confused with surds, it's a good idea to maybe think of it as a variable, think of it as x. Now if you had 5x plus 2x, you know that would be 7x. Same here, 5 root 2 plus 2 root 2 is 7 lots of root 2. Again here, before we collect any like terms, we need to simplify each surd. So if you have a look, 28 is a multiple of 4, 45 is a multiple of 9, and so on. We're looking for multiples of square numbers. So on the next line, I've written each of these values inside the surds as multiples of square numbers. I can then split those products. So root 4, root 7, root 9, root 5, etc. And then I can actually replace root 4 with a 2, root 9 with a 3, root 16 with a 4, root 16 with a 4. And I can simplify. And now that I've simplified each term as much as possible, I can actually collect like terms. So 10 root 7 minus 16 root 7 is minus 6 root 7, and 6 root 5 plus 12 root 5 is 18 root 5. All right, same thing here. Each of these surds can be simplified because we've got multiples of square numbers. I can then split those products. I can then rewrite root 9 as 3, root 25 as 5, etc. And then I can collect like terms. So 3 root 3 plus 10 root 3 is 13 root 3, and 5 root 2 minus 6 root 2 is minus 1 root 2, but we don't need the 1. All right, this is kind of the opposite direction. This is already written in its simplest form, and we want to put the 5 back into the square root. So we just need to think about the fact that 5 is the same as root 25, and 3 is the same as root 9. So if we rewrite the 5 and the 3 with those surds, and then we can merge those products, we get root 25 times 6, which is the same as root 150, and same here, root 18. Okay, again, I'm allowed to merge this product. So root A, root B is the same as root AB. Gives me root 50. And over here, the order doesn't matter when I'm multiplying, so 4 times 6 is, I can do 4 times 6 and then root 7 times root 7. A root multiplied by itself, a surd multiplied by itself, is always the number inside the surd. So root 7 times root 7 is 7. You can think of it as root 49, which is 7. All right, so on this side we get root 50, which then can be simplified further by the usual process, and here we get 168. Okay, here we've got a fraction. I'm allowed to simplify those, and I'm allowed to merge this fraction. Be careful with trying to simplify, for example, the 20 and the root 32. That's inside the surd. This is not, so just be careful. So the 35 and the 20s cancel down to 7 and 4. I can merge these two together. It's a division, it's a fraction. So that's the same as root 32 over 8, which is the same as root 4, which is the same as 2. Now that all the surds are gone, I can just simplify as usual, and the answer is 7 over 2. Here I need to expand and simplify. So taking each term at a time, here I've just done the multiplication. That times that, plus this times this. And if I take each one in turn, that's the same as 12 times 5 and 18 times root 100. And they simplify, and then we can find the answer. All right, for B, be very, very, very careful. You will be tempted to just square each of these, but you know that you need to expand the brackets. You know that this squared means the whole bracket multiplied by itself. So that gives us that, and if we multiply out each of the terms, that's what we get. And then we can collect like terms. So minus 20 root 3 minus 20 root 3 is minus 40 root 3 plus 25. And then those two are like terms, I can put them together. We did a lot of this in trig, so shouldn't be a problem. Rationalizing the denominator. Remember, you need to just multiply by the surd itself. So root 5 over root 5, root 3 over root 3, because we need to keep the whole fraction equivalent. Okay, that gives us 2 root 5 over 5, and 5 root 6 over 2 times 3. Again, be careful not to try and cancel those two. That's inside the surd. This is not. Last question, challenge. Probably try this on your own. We're trying to write this with a rational denominator. Press pause, and when you're ready to see the answer, press play. Okay, so for this you had to think back to dot difference of two squares. If you remember, the difference of two squares happens when you multiply a sum by a difference. So if I multiply this by the same term but with a plus instead, I end up squaring both of the terms. If you're not sure about this, multiply those two out in detail and you will get this. So that gets rid of the surd. And then the last, you can leave it here, but if we want to simplify fully, we factor out the 2 in the numerator, and then we can simplify the 2 and the minus 4. Okay, it's been fairly quick, but hopefully that was just a reminder.